All right, thank you, everyone. Yeah, so we are Broadberry Data Systems, and I just wanted to speak to you about what we have to offer these days for the direct-to-chip cooling and for the immersion cooling systems. They're already out there. You can install them in your immersion cooling baths, or you can obviously utilize the Carbon Z. But before I start, let's touch a little bit about the Broadberry itself, because I don't think... Who knows Broadberry? Can you raise your hand? Okay, we've got a few hands, so that's good. Yeah. So overall, Broadberry was established in 1989. So it's a company with a long tradition, and the guy who you see out there is the guy named Colin Broadberry. So he set up initially a company building PCs, but obviously in the 90s, when the .com started booming, he noticed that, in fact, no one is actually building any sort of systems which are rack mountable or anything like that. So he started doing that, and since then, obviously, we are happily providing our customers with plenty of different solutions, and indeed, all of them back in the day were always air-cooled, but obviously now we're coming into the stage where we will have to consider using water cooling. So Broadberry itself is the part of the very big group which is multinational. So we are a part of roughly about 80 different integrators and also the industrial integrators. Overall, the company itself has the direct relationships with the vendors. So Supermicro, Asus, Tyan, Toshiba, Gigabyte, you name it. Obviously Intel as well. We are a Titanium partner with Intel. Because of it, you can actually get the expertise directly from them and from us. And another thing is as well, is obviously it's much easier for you to integrate the systems when you have this direct connection. So when you come on our website, what you can do, and we are actually very proud of it, is that if you're ever having a project to work on, you can go onto our website and configure any system you want, however you want it to be configured. Is it 1U, 2U, 4U, 8 GPUs, 4 GPUs, you name it. And immediately for your project budgeting, you will get the pricing and the PDF you can generate with, which again is something which is really, really good, because thanks to the system, we are actually pulling in all the data directly from the vendors, and prices keep on updating every single day. So you always have the most accurate quotes straight once you just go onto the website and configure it. So that I highly encourage you to do so. Obviously, Broadberry, apart from the servers, does the workstation solutions as well, which is immediate part of any office, and obviously the storage solutions as well. But obviously what I wanted to touch on today is why you want to bother with liquid cooling. Not sure if you guys heard about this, but there was a leak from NVIDIA guys, which sort of like leaked out the roadmap for the GPUs. And what happens is that obviously they're planning on releasing the chips which are going to consume even more and more power. So at the moment, the H100 machines, the GPUs, they consume roughly about 350, 400 watts. H200s are going to consume about 700. And there are rumors already that B100, it's going to be a GPU which will take about 1,350 watts of power. So I'm not sure if you've seen already, but there is plenty of air-cooled data centers where when you're coming in and you see a whole rack cabinet and only one server in it, right? That's the thing, because the GPUs are consuming so much power that air-cooled rack servers or traditional data centers are, well, not entirely capable of cooling it properly, which essentially means that you're wasting a lot of space in the data center. So now, why? That's why I think in roughly about 2025, all you're going to see, if you want to go to the high-end computing side of things, all you're going to see is only water-cooled stuff. So that's why I'm really glad we have so many people here today, because I think personally that's where we're heading. And the traditional data centers will only be there to, I don't know, host mid-range 1U systems. So yeah, so as you can see, like, you know, even the latest generation, like a CPUs, they are already consuming about 400 watts of power, right? So if you're planning to do like a high density build, let's say a rack full of, I don't know, like a 20 node 7U chassis, you won't be able to put any sort of like a top of the range Intel Platinum CPU or like AMD. That's just literally not possible, purely for the constraints of the high density systems. So that is why we simply need to make sure that we go onto the well, liquid cooled solutions. And as you can see, like, you know, the per rack, the air cooling has only a capacity of roughly about 25 kilowatts. Then you go to the direct-to-chip solutions, that ramps up roughly about 48, 50, and anything beyond that is immersion-cooled stuff. So again, if you ever consider your highly demanding AI workloads, the only answer is liquid-cooled. So now I just wanted to show you a bit of our direct-to-chip solutions. So we already have, and these are ready on the market. You can already go and purchase them. You have the direct-to-chip. These are HGX machines. So each of them, and also Intel Gaudis actually, you have the old direct-to-chip cooling on the SXM. There is eight GPUs. And plenty of compute power in them. Another range of the systems is the high density, and that's what I mentioned to you guys. Like, you know, on average, if you want the air-cooled high density system, it can only take roughly about 180 to 100 watt CPU. You do have the CPUs though, which are taking 350, 400 watts. So that is why we're coming in with the direct-to-chip solution. But what I wanted to highlight is, obviously, as the guys mentioned, direct-to-chip is a bit difficult with maintenance. But fortunately, when you put your servers in a Carbon Z, you don't really have to think about it. But you do have these valves where you can just simply unplug the system from the rail, which is next to the rack, and you know, unfortunately pull it out. And that actually locks in the fluid which sits inside of the heatsink. So you won't spill anything. That's the main thing. And that is why, as you can see, we do have these high density solutions. And in fact, one of these, I did test the Intel 8480s in there, and loads of RAM. We did have a customer who wanted 256 gig RAM sticks populated in each node, full of them. So there was roughly about 6 terabytes of RAM per node, and 2 of the 8480s. And if we wouldn't use the low register RAM, which has a slightly smaller thermal envelope, there is no way these nodes would run properly. They would simply crash because of the temperature. So now again, we're coming to direct-to-chip, and that problem is gone. So you can very quickly populate the entire rack of hardware and have in one rack, let's say, 40, 80, about 120 nodes capable of doing your HPC compute. But obviously, from time to time, you do need like a standard 1U system as your admin node. So we do have those as well. And that's, as I said, already on the market, and you can, well, already consider it. And all of them have been tested and verified, and they are fully certified to work with the Carbon Z solutions. And this is the most interesting one, because the thing is that obviously the immersion cooling solutions, as you can imagine, because there is so many unknowns, unfortunately a lot of vendors are still saying like, well, we cannot fully warrant the solution we sell to you, so you can't put any server in the immersion bath, purely for the reason that the oils have a different specifics, the labels will peel off, the paint will peel off out of it. So what you need to do, well, fortunately, what we did with the vendors, we certified it for certain solutions, which are in fact the solutions used here in Carbon Z. So it's Submare and GRC. These solutions are fully immersible, fully certified, and you do get full warranty on them. And in fact, because we have so much trust in immersion cooling solutions, we actually extend the nominal warranty. So we do, instead of standard 3 years of warranty, for these systems, we actually give 5 years warranty. So yeah, so the immersion cooled 2U system, 8 GPUs. And you can dip them straight in a bath. And in fact, they are very easy to maintain as well. The other platform, which we did discuss as well about the storage, I think this is a very interesting approach because in fact, the storage bays are on the side of the servers. So when you pull them out, as the guys mentioned earlier, you don't actually have to dry the system or anything like this. You can do it live. And these nodes, they both support 3.5-inch disks, 2.5-inch drives, standard SATA and SAS, and also NVMe disks. So you have a full palette of systems and well, disks to pick from. Another one is, yeah, it's a little bit about the standard sort of like a 4-node system with the 2 NVMEs for caching and the rest for the capacity tier. This system, which you do see here, which looks like a standard 2U 12 bay, actually can support as well 3 GPUs. And it's fully certified again for the immersion baths using the castor oil and GRC and Submare baths. So yeah, so obviously for the cooling comparison, we can see, and I guess, well, the guys already mentioned plenty of times what are the benefits and what are sort of like pros and cons for it. But what I wanted to tell you as well is that, in fact, by engineering these solutions, well, earlier on the air-cooled, we came up with the solutions for the pod architectures for the GPUs, which would be direct-to-chip cooling. And these solutions are fully blown solutions for the AI, which consist up to 128 GPUs. They are fully configured, and the way how we do it is that we would ship pre-configured racks, which can just go into the data center, be plugged into the main rail here, and yeah, and you can enjoy the benefits of water cooling. Again, why you want the water cooling on these systems? Standard air-cooled systems, they will obviously work, but you cannot overclock them. With these guys, you can increase the CPU, you can increase the GPU and the GPU memory. You can increase the megahertz on it literally right to the top. And they will still work like even on the lesser temperature, the nominal working temperature for the standard air-cooled system. And obviously that's another super pod architecture solution. Everything is connected over the InfiniBand, so in fact you can scale as much as you want. You can start with one rack and you can start scaling even more and more and more depending on your AI workloads. Okay, and the last thing is what I wanted to discuss with you as well, guys, because obviously along with the water-cooled solutions and the AI, no one actually speaks about the storage and the demand for the well, high-speed storage in the AI workloads, especially with these days with the emergence of the CXL extended memory disks. We came up with a solution, well, not entirely us, to be honest with you, because the Deos storage solution is a scale-out solution which came out from the Intel stable. But Intel themselves, as they are great guys, they decided to release it under the Linux Foundation, and now it's being heavily developed. This particular system is being heavily developed, well, through a lot of big companies, because the thing is that it's the only file system which allows you to commit your writes in an asynchronous fashion. And what it means is that usually the scale-out systems would always face the problem of having a huge latency on writes. Unfortunately, with utilization of the NVMe technology and the CXL technology, that sort of like a issue is no longer there. But looking on the benchmarks, if you like, for example, like if you look on the top of the range HPC benchmarks, Deos would be the one of the first, but I'll show you this later. So how it works. The Deos has its own native clients for different workloads, and it works as a sort of like a containerized pools. So you can, for each of your workloads, like a POSIX, MPI, Hadoop, S3, TensorFlow, you can create a separate pool of storage out of all the storage you have in your cluster and assign it to your workload. And because the client, the Deos client, is optimized for these workloads, you can rest assured that, in fact, it's going to be, well, I don't think there is any sort of other technology out there which is capable of passing the data from the storage system out to your GPUs or CPUs in this sort of a fashion. So again, I would like to really encourage you, because the thing is that the Deos storage, Broadberry's been working with the main contributors of Deos, and in fact, the ideal thing about this is that, well, it's open source, so you can test it yourself. But as we're working with the main collaborators of Deos, we're actually coming out with the enterprise solution for it. So we have the full support for it. We're working on the web GUI for the less technical people whenever they want to change something. And overall, I think it would be a great addition to the standard, like to the data center like here. Because again, one of the biggest problems, and I continuously having this question from the customers, is like, I need to run a bigger model. How I can do it? Like, I don't have enough VRAM. I don't. And well, the answer is, I know it's not as fast as RAM, but it's very close to be fast as RAM. So, as I wanted to tell you, who's is using Deos storage solution at the moment? So the Deos storage solution actually has been deployed worldwide, and with the latest SC23 in Denver, some of the research institutes, they did post their cluster builds and the performance of it. And what you're looking at the moment is the performance. Well, there is a website called IO500, which tells you, well, which has a list of all these different clusters. And as you can see, first one, second one is Deos, and the sixth one is Deos. But if you look on the client nodes as well, and that's a very important thing, the first cluster, which roughly topped with 10 terabytes a second, was only 300 nodes. The another one was 90 nodes. When you look on the third position, which says it's Lustre, 2080 nodes. Right? So again, you can really bring the density of the system and literally have one air-cooled rack for your storage, or even liquid-cooled, thanks to our immersion-cooled storage solutions. And you can run it alongside of your system, of your GPU or CPU, DTC or immersion-cooled systems. And I think it's a very good addition to what you guys do. And I would really encourage you to look into Deos. And obviously, if you do have any questions, I'm over there. So yeah, so Deos storage solution can take, we have a special node for it. So then again, DTC and air-cooled. But as you can see, we have a very big density 1U systems for it. So for example, this one can take 24 NVMEs, and each NVMe can be 30 terabytes. So, well, you do the math. Yeah, so you can literally, in just a couple of years, have about 2-3 petabytes of all-flash storage. And yeah, and why we're working with Carbon Z as well is that because these guys have fantastic expertise when it comes to the DTC solutions and the immersion-cooled solutions. So we're working on the hardware side of things. Carbon is helping us out with the large projects and placement of them here in Swindon. And as a final thing, I just wanted to sort of like show you a little portfolio of our key customers. And as you can see, but obviously we're working with plenty more as we've been in the business for over 30 years. But as you can see, we are very multinational and working with a lot of organizations which we do help with, especially around the AI workloads. Okay, and that's my last slide, guys. So obviously, yeah, we are worldwide. So our headquarters is in London. However, we do have offices in USA, East and West Coast. We have offices in India, office in Germany, office in Australia, and just setting up one in Japan.